Due to the limitations which were seen in the Bose model, further studies were carried out in order to still derive a better structure for the model of atom. And as the study progressed, two of the theories came up, and these two were the dual behavior of matter and Heisenberg's uncertainty principle. Let us study, because as we are reading the first one, that is dual behavior of matter, we get a bit confused because little previously that we have learned about the dual nature of electromagnetic radiation. That is, an electromagnetic wave behaves like a wave and that of a particle. And now we are talking about dual behavior of matter. Let us take up with our study. The French physicist de Broglie in the year 1924 proposed that matter, like that of electromagnetic radiation, should also exhibit dual behavior, that is, both like a particle and wave-like properties. This means that just as a photon has momentum as well as wavelength, electron should also have momentum as well as wavelength. De Broglie further gave an equation which related lambda, that is wavelength, to that of momentum. He said that wavelength of the moving particle is inversely proportional to its momentum p. P is a product of mass and velocity. Hence, we can give the equation as lambda equal to h divided by p, or lambda equal to h divided by mv. The next important development was the Heisenberg's uncertainty principle. Heisenberg stated the uncertainty principle with respect to the position and the velocity of the electron while it is revolving around the nucleus. So according to him, he said that it is impossible to measure simultaneously the exact position and velocity of a very small particle such as electron with absolute accuracy or certainty. Hence, he further expressed his statement by giving a mathematical expression as delta x. Delta x is the change in the position or uncertainty in the position, multiply by delta p. Delta P is the uncertainty in momentum. Momentum is a product of mass and velocity, is greater than or equal to h by 4 pi. That is, the product of uncertainty in position and uncertainty in momentum can be greater, or it will be equal to h by 4 pi. This tells us that at one point I cannot say that this is the position which is gained by the electron or this will be its velocity. There will be always a inaccuracy or a uncertainty which will be involved with respect to a position or the momentum. Okay, so this is what has been taken up under Heisenberg's uncertainty principle. So I cannot say when a electron is revolving around a nucleus, this is the position of the electron. So I can say, probability of finding the electron can be there in this particular region. So this probability of finding the electron is based upon our Heisenberg's uncertainty principle. The significance of uncertainty principle is that it rules out the existence of a definite path or trajectories of electron and other similar particles. That means it says that there is no fine circular path around a nucleus in which the electron will be moving. Hence now the concept of orbital came into picture. What is an orbital? An orbital may be defined as a region in space around the nucleus where the probability of finding an electron is maximum. It is a region around the nucleus where the probability of finding an electron is maximum. Certainly that now when we have come up with the concept of orbital, you may have one confusion in your mind as to just earlier that we have studied about orbit and now what is orbital, okay? Because orbit is something which is against the Heisenberg's uncertainty principle, because orbit is a circular path which is traced around the nucleus by an electron. Whereas, according to the Heisenberg's uncertainty principle, we cannot locate as to, a particular position or the velocity of an electron at a given time. So we talk about the probability over here and hence the term orbital for it. So it is like probability of finding the electron in a particular region. So let us see, is there a difference between the two? Yes, certainly it is having a difference. What is a orbit? Orbit is a well-defined circular path around the nucleus, whereas orbital is a region or a space around the nucleus where the electron is most likely to be found. Okay, now when I talk about orbit, it represents planar motion. So I'm talking about just one dimension over here. Whereas when I talk about orbital, I'm talking about the 3D motion of an electron. So here orbital talks about the 3D motion all around the nucleus. When I talk about the electron availability over here, the maximum number of electron will be 2n square, where n stands for the number of orbit. That means when I'm having the first orbit, it will be n will be 1. So 2 multiplied by 1 square. The answer is 2. The first orbit will have 2 number of electrons in that. So if I'm having the second orbit, how many number of electrons will be there? Correct. It's 2 multiplied by 2 square. That is 2 multiplied by 4 and the answer will be 8. So that second orbit will have 8 number of electrons in it. In an orbital, we cannot accommodate more than 2 electrons. Or orbital or a region around a nucleus when there is maximum probability of finding an electron will be 2. Just 2 number of electrons. When I talk about orbit, it is non-directional because we are giving it in a planar motion, whereas in an orbital, it can be directional. So that is what we are talking about orbit and that of a orbital. So, or within the orbit, I will have orbitals which will be present. Okay, and these orbitals will be taking up with different shapes depending upon the probability region in which the electrons are found. So let us see this further. We can be also differentiating orbit and orbital with a simple diagram.